Welcome everyone to today's presentation on Earthwork Processor and the Civil 3D tool by CTC. This is a behind the curtains look. My name is Brian Lewandowski. I am the Civil Product Manager here at CTC and I'll be doing the presentation. So what is Earthwork Processor? For those of you who don't know what it is a robust tool to calculate complex site earthworks per region. So for example, in the screenshot I have here, perhaps there's different hold down depths for different portions of my site, for heavy duty pavements versus light duty versus topsoil, that sort of thing. Earthwork calculations in this way can be quite complex. Earthwork Processor automates all of that for you. It also accounts for topsoil stripping, and it can automatically label or hatch or tabulate or export results to Excel to aid in all that reporting and plan production portion of that earthwork analysis. You can save out templates, for example, common analyses that you might conduct from one project to the next. You can save that scenario and easily repeat it in future projects. So really handy. So the workflow in Earthwork Processor, you basically define earthwork sets. This is the interface down here. You assign proposed and existing surfaces. So the presumption is that you already have that information, preliminary proposed grading inside your drawing. And then you use or choose subgrade regions. These could be polylines, they could be feature lines. And they represent the different portions of your site like this. And what's different about them is the subgrade depth or the hold down depth varies. And so you would draw or create polylines or feature lines representing those different areas. You can set stripping depths and cut and fill factors, and then Earthwork Processor does the rest. It calculates earthworks per region, cuts and fills, less the hold down and stripping depths if you plug that in. Okay, so it does a ton of work for you in a really automated way. And then if something like the proposed surface changes, or perhaps the hold down depth, one of the areas changes, you can just simply rerun the earthwork set and all the numbers will update. And then from there you can label things, tabulate, export, you name it. So that's the gist of what Earthwork Processor does, and a lot of you might be using it already. So the purpose of this presentation or this webcast is to kind of roll up our sleeves and look at how is Earthwork Processor function and how do I get it to really work the way I need it to. This step 4, we got 2 step 4s in fact. This step 4, the second one, does a ton of stuff in the background, and that's the first focus or the primary focus of this presentation is how is it calculating earthworks for me, right? That's an important piece of this because we need to be able to trust the tool, what it's doing, because that's a huge portion of the cost of our projects. So I'm going to jump into Civil 3D and we're going to use Earthwork Processor a bit, and we're going to talk about some of that kind of behind the scenes stuff and how this functions. It's going to be a fairly kind of nitty gritty presentation. So I encourage you guys to ask questions again, because the purpose of this is not to just give you a quick overview of what the tool does, but for you to understand of how it's functioning so you can trust it in your own projects. So again, yeah, ask questions as we move along here. So this is the Sim Project Suite up here, and inside that is Earthwork Processor. What I have set up already in this drawing is a proposed and an existing surface, okay? I have those turned off in plan view, though they are showing over here in my model view. I also have some polylines drawn that represent topsoil, heavy duty pavement, medium duty pavement, as well as a sidewalk concrete area. These are different hold down depths. And so what I'm after to calculate my common earthwork is to be able to generate a surface that is a variable depth across the site, right? So if I look over here in my profile views, here's my existing, here's my proposed. My subgrade surface would be some kind of distance below this, but the depth would vary depending on these different areas, okay? This is a simple commercial building site example, but it applies to all kinds of road work where corridors won't meet the grade, or residential projects, or you name it, lots of different applications. This is just the example we are taking today. So let's launch Earthwork Processor, and that's done right up here. Now notice there's two functions here, that calculate earthworks and then offset earthwork regions. This is a simple function that allows you to do automated offsetting of your subgrade regions. One of the things that Earthwork Processor does is it makes a surface out of these subgrade regions. If you're familiar with break lines on a surface, you know that you don't want break lines to overlap in this way. And so the second function here will automatically offset all that stuff. Some of our other Intro to Earthwork Processor webcasts go through that in more detail. Our focus, again, is going to be understanding behind the scenes what it is doing. So let's click Calculate Earthworks and open up Earthwork Processor. So it works by defining an earthwork set. You can name these whatever you want. I'll just call it EW for earthwork. Then I'm going to assign my proposed surface in the proposed column and my existing surface in the existing column. And then the third piece that the tool needs to be able to calculate cuts and fills per area is to know which objects represent those areas. These are those 4 different colored polylines out here. I can select them in the drawing, or I can just choose by filter. And I can use perhaps some asterisks or something like this and say, grab everything on a particular layer, on layers that start with ERWK. You'd use whatever standard you have to match your layering or your styles or your sites, okay? Now I'm using polylines. Use polylines if your hold down is constant across that region. If you actually have a variable hold down, you would use feature lines. And we'll explain a little bit more how and when you would do that in a bit. From there, the tool scans the drawing and it finds all the polylines that met that filter criteria. And there happens to be 4 of them here. You can click on the zoom button at any point and it'll zoom to those particular regions if you have a really large site. Some of the behind the scenes stuff right off the bat, how does it know how to name this stuff? Well, that's taking a layer name. But if you look in options, there's options here for use object layer or use object name. So if you're using feature lines and you've named those feature lines in creative ways, you can have that pulled through instead of the layer name. Now, after the fact, you can certainly name it how you want, but that's just the starting point. From here, Earthwork Processor has everything it needs to generate some simple earthwork volume. So I'm going to click Run up here. And then right in Earthwork Processor, we're going to see we've got a number of cuts and fills per region. We also have a total for the overall, for the sum of all these regions. And if we had multiple earthwork sets for different areas in our project, we would see a total across the entire set of earthworks defined in here. Now, how is it coming up with this? This is the main focus of our presentation today. How does it come up with these numbers? Okay, we are using surfaces, a series of surfaces in Civil 3D to generate these volumes. And that's what I want to show you today, how that works. Let's take a step back and talk about volume surfaces and what they are. For example, there's this volumes dashboard option in here. And while it serves its purpose here and there, it doesn't really cut it when we're trying to do complex earthwork calculations like this. But let's go ahead and just say we're going to create a volume surface where we compare existing to our proposed. And this would be to just get really kind of crude cuts and fills, right? And if I hit OK to this, it generates a surface. That surface shows up right over here. Now I just let it be called surface 2. But what is a volume surface? It's called a volume surface, but it's not actually a volume. It's still just a tin surface. And let me illustrate that to kind of showcase this. What is a volume surface? Well, it's the comparison of finished grade and existing in our example here. I'm going to go ahead and take, let's move tool space out of the way here. I'm going to take this alignment, and this is a north-south alignment I have that's contributing to these profile views. And that's how we're getting these profile views right here. So the left side right here corresponds with the bottom side right here. I'm going to go ahead and create a surface profile of that new volume surface I just made. So what would that look like? We might think it would be all the area in between these two. I'm going to go ahead and hit add. We'll hit OK, and this will show up in my profile views. Okay, this is that surface 2. These are two separate profile views. This is down at elevation 0, near elevation 0, whereas my site is up around 800 and so. So specifically, what is a volume surface? It's not a volume. In fact, it's a tin surface whose elevations are the delta between the two comparison surfaces. So for example, right up here, the elevation of this is 834 and something compared to about 832. What's the difference between those? 2. If we look down here, what am I getting? I'm getting approximately, well, it's -2 in this case because of how I chose the comparison surfaces. Okay, so a volume surface is not an actual thickness. It's simply another tin. This is my volume surface down here. Okay, if I were to look at this, there is no thickness to it. It's just another tin. Okay, so this premise or concept is what we use in Earthwork Processor, and we build on that to generate the volumes we're after. I'm going to delete this volume surface. That was just an example. But instead, we're going to look at Earthwork Processor now and see what it is doing. When I ran my Earthwork set, what it did was create a surface folder over here based on the name of the set. And then inside that, it created 4 separate surfaces. It does all that work for me. So how is it generating those N volumes, right? First thing we do is we take the polyline regions, the subgrade regions, and this is what Earthwork Processor is doing, and it's throwing them all into one surface as break lines. Now, the elevations of those polylines is equivalent to the depth of the hold down, not the elevation, but the depth of the hold down. So for example, if I pick this topsoil polyline and I look at the properties of it, the elevation of it is 0.5. Okay, that topsoil polyline is brought into Earthwork Processor. If I go ahead and open up Earthwork Processor again, I'll see for that turf or topsoil region, a depth of 0.5 is pulled in, and that's my subgrade depth or my hold down depth. Okay, that's the delta from finish grade, not the actual elevation. Okay, so we take those 4 polylines and we make a surface out of it, and that surface sits right down here near 0. If we go ahead and cut a profile of that surface, subgrade depth, we'll hit add to that. I'll hit OK. This is a simple surface. Let's go ahead and put labels on it. This is my earthwork depth surface. Okay, this does not alone give me the volumes I'm after. It's a simple surface with polylines in it for break lines, whose elevations represent the depth below finish grade that my subgrade surface should be at. Okay, if you look at the elevations, we have 1.5, 1 foot, right? Okay. Now let's go back to that volume surface example. What is a volume surface? It's the difference between 2 tin surfaces. The elevations of a volume surface are the delta between 2 tin surfaces. If I compare finish grade to my depth surface, I will get a surface that is finish grade elevation, say 830, minus the depth surface, say 1 foot. So I'll get a subgrade surface that is 1 foot below. Over here where it's 1.5 foot hold down, I'll get a subgrade surface triangulation that's 1.5 below proposed surface. That's what this surface is right here, the subgrade volume surface. It's a composite, a comparison between the earthwork depth surface and the proposed surface. Pretty straightforward. Let's go ahead and add that into our surface profile. And okay, and here is my subgrade surface. Okay, that's what we're after here, right? Here's my 1.5 foot hold down. That applies to the cyan area here where there's heavy duty pavement. Here's my 1 foot hold down, 1 foot again. And then in this area, I've got an 8-inch hold down, okay? That is the subgrade surface we're after. Now there's one other step that Earthwork Processor does, because since that's a volume surface, we can't then take that and compare it to existing ground. You can't create a volume surface from a volume surface. So there's one other trick we do, which is to take the subgrade volume surface and paste it into a regular tin surface, okay? Earthwork Processor does all this in the background, but they're standard native commands. And some of you might have even been doing some of this. It's a workflow that's been around for a lot of years, but it was really cumbersome and it was quite tricky to kind of keep track of. Earthwork Processor does all of it for us. So if I add the subgrade surface to this, it's the exact same geometry as the subgrade volume surface. So I'm not going to bother with that, but let's go ahead and make sure we put our labels on here so we can keep track of what surface is what. Okay. And then finally, if I have my subgrade surface, I can then compare that to my existing, and that's what this final earthwork surface is. It's a volume surface that's comparing earthwork subgrade to existing. Earthwork Processor then, in a similar method to the volumes dashboard, where you can add regions and calculate volumes per different areas, it then breaks out those cuts and fills for those particular areas. Now everything is dynamic in this way. The subgrade surface is based on comparing the depth to the proposed, okay? The depth is based on these polylines. So let's say we change the elevation of the polylines. I can do that right here by just a simple polyline edit, or Earthwork Processor, in fact, will handle that for us. So say the heavy duty pavement, the hold down is not 1.5, but instead 2 feet. I'm going to run this again. When we close out of this, what we should see in this heavy duty pavement area, we should see this drop down another foot. We should also see the depth surface profile move up from 1.5 to 2. I'll hit run. And if I close out, we should see that refresh over here. Let me run that again. Maybe it did update and I missed it. Oh, there it goes. Okay, so that's now a 2 foot hold down. The depth surface moved with it. Because those surfaces are linked into the earthwork surface through here, those volumes are updated, and then Earthwork Processor divides those out per subgrade region to get cuts and fills per region. Okay, so it's just some surface trickery in the background. So there's a question, what about topsoil stripping? That's our next step here, okay? How does that factor into it? What would my earthwork surface be if I had a stripping surface? Right now, my earthwork surface is comparing subgrade to existing. But what we in fact want to do is compare the subgrade surface to a stripping surface. So if you specify a stripping depth, let's put in 1 foot for all of these. and you can specify per region here. It's going to generate a stripping surface for us. So let's go ahead and run this, and then we'll add that stripping surface to our profile view as well, so we understand what that is. But notice that I'm now out of cut and I'm getting fill here, right? And that's because we're now comparing in our earthworks volume surface, we're comparing it to the stripping surface. So what does that stripping surface look like? Let's add a profile of it. That now shows up right here. I'll add that, I'll hit OK. And there is that stripping surface showing up. Let me give it a different style if we can. Okay. The constant, the continuous line stripping surface, okay? And it's fairly straightforward. It's just 1 foot below existing grade. We're now comparing that. My existing surface isn't quite extended in this sample file. That's why you're seeing some of that. But now what Civil 3D or Earthwork Processor does is it compares the subgrade surface not to existing, but instead to the stripping surface, okay? And that's how we're getting then different volumes. Now, what is the stripping surface? What we do is we paste in the existing surface, and then we provide point lowering operations to all of the surface areas within these subgrade regions. And there's another question here that came in. What about if my stripping varies across the site? Okay. Now we do have a webcast out there that dives into that in detail, but I'm going to briefly explain it to you. I'm not going to walk through all of it here. But the scenario is this: we don't simply have 1 foot stripping across the site. Let's say instead there's some areas, and it might even be defined by some other polylines. I'm going to provide a simple scenario here. Perhaps there's an existing concrete slab that needs to be removed. That slab is 4 inches deep, and there's some material that we're going to excavate. So let's say the total stripping there is 1.33 feet. And then maybe there's another area over here where there's some contaminated soil, and I know we need to excavate 5 feet there. And then maybe over here there's just some decent topsoil, right? Basically, there's variable stripping across the site. When we have this scenario and we can't define our stripping based on our proposed subgrade regions, and we're instead defining stripping regions, the solution is simply to create another earthwork set. And it would look kind of like this. Your existing surface would still be existing, and proposed is proposed, but the regions you select would not be those proposed regions. They would instead be the stripping regions. And then what you're going to end up with is a subgrade region from this set. This subgrade region is based on, this would be existing right here, okay? The subgrade region would be the existing subgrade region, right? Or the stripping surface, okay? And then when you get the subgrade region or surface from this earthwork set, you would apply that to here as your existing surface, instead of using your top of existing, you'd use your existing subgrade. Okay, kind of a quick overview of it. Again, we've got webcasts. Go to CTC Software on YouTube and look up the Earthwork Processor, or if you have the tool, you click the videos button in here, and it's going to bring you right to a playlist on YouTube with all the Earthwork Processor videos. Okay, I go through some of this, and I think it's this video here, so be sure to check that out. So yeah, good questions. It all depends on the complexity. If there's no stripping across your site, or if it's just a constant like 6-inch topsoil stripping, just make the one earthwork set, okay? If the subgrade surface for existing or the stripping surface varies, then you have to define those stripping regions, make one earthwork set, take the subgrade output from that one and plug that in as your existing surface up here. Good questions. Be sure to keep asking anything else that's not making sense here. Again, the important thing is that you guys understand what Earthwork Processor is doing so you can trust it. Now, some of the other stuff behind the scenes here, Earthwork Processor can label things. Let's go ahead and turn on our labels. We're going to label all of the different regions. Click Run again. I'll close out, okay? What it does is it inserts labels for every one of these regions. We've got some nice kind of centroid algorithms built in, so it finds basically the centroid of the largest area and puts it there. And then it labels what you want, okay? Now it's a piece of M text. So you can certainly move it around, like perhaps this one we wanted maybe a little bit more centered here, okay? You can move things around like that, but every time you run Earthwork Processor again, it's going to update that stuff. For example, let's say the hold down depth here was 0.33 instead. Okay, that should affect my volumes in this turf area. So I'm going to click Run again, and you'll see these numbers update right here. So we reach out and we update those labels, that M text, to reflect the new volumes. Did I miss something? Didn't see it update. Oh, there they go. Sorry about that. So what contributes to these labels? If you go into options here, there's a labels and reports tab, okay? Under labels, there's a list of all the different things we can label and that are appearing in our labels. If you choose the little ellipsis button here, we can turn on different pieces. Maybe I don't need to see proposed and existing. Maybe I don't need name. But I want cut and fill and stripping volume, maybe no net. Hit OK. All my formatting options are here. Do I want to use the units as a suffix, prefix the field name? Okay, I can change all that stuff in there and run that again, and those labels will update. Notice it didn't change the location of my label. So if you move it to a more preferred location, Earthwork Processor won't change that, but it will continue to update those numbers as things change. Some other stuff and options here. If we start on the General tab, okay, these earthwork sets, as I mentioned, can be saved out to templates, okay? The default location where those templates save is right here. When you create new earthwork sets, what is the default cut factor or fill factor that's assigned? We're going to assign that here. What is the precision? Okay, if we're working in a metric system, we perhaps want 3 decimal places. And then do you want to see the totals row? You can turn that off or on down here. The surface creation tab. We're generating a lot of different surfaces with Earthwork Processor. All of these styling is managed through here. So there's a default so that as you create earthwork sets, it automatically assigns. I've got one here called model only, where the surface shows up in a model view, but not in a plan view or profile view. Okay. You could make it so all those earthwork sets follow the default, or you could override them independently. There's another setting in here as well. We're generating surfaces by initially adding break lines to a depth surface. Okay, the level of detail in your those surfaces is a consideration as well. So back on the surface creation tab, there's a break lines column, and in here it dictates the supplementing factors. This is the level of triangulation that we get in these surfaces. So if your subgrade surface isn't quite looking detailed enough, right, and you don't have a constant hold down from your finish grade, dial up this detail a little bit and you should see some improvements. Down here is shading. We can automate surface elevation analyses on our surface by spelling them out here. And here's the labels we talked about. And then Excel report, Excel or AutoCAD table reporting is an option as well. So let's run that one. So if I take my earthwork set, I've got create AutoCAD table or export to Excel. I'm going to create an AutoCAD table. And it generates that based on a table style in my drawing, in my template. Now, if that's not what you want to see in your tables, perhaps again, we don't need to see the name of the surfaces. Maybe I don't need to see the net, or I only want cut and fill, whatever the case may be, or maybe just the formatting, the precision on it. Okay, how all this comes out is customizable in the options of Earthwork Processor. So let's go back in there, go to options, labels and reports. So let's say for this, again, I don't want proposed and existing. I don't need subgrade depth, okay? Now, if you want to customize the precision or the display of any of these, if I double click into those, I can control first how the header, what the header looks like, right? Maybe I just want stripping and not stripping volume. What are the units it's going to display? Now, this is specific to the Excel and AutoCAD table reporting. What's the precision? We can dial that up or down. And then what kind of rounding might we apply? And you can do that very independently. And then furthermore, what is the order of the columns? Maybe I want stripping volume and then net. Do I want to include headers? Do I want to include units? Do I want totals at the bottom? Maybe I don't need that. And then down here, these settings apply to all your labeling and your tabling options. The decimal character, digital grouping, and the symbol. So I hit OK to that. I'm going to click that earthwork set again. We'll create a updated table. And now it's a simpler table without that information I want. Now, how this centers in the cell, that's all your table style. That's all standard Civil 3D or AutoCAD table styles rather. So you can manage all that just through standard means. So Earthwork Processor, a lot of the kind of behind the scenes control over what your stuff looks like is in options. These are app-wide settings, meaning when you change things in here, it applies to every drawing that you might work on with Earthwork Processor. When you make changes in the main form here, these are settings specific to this drawing. Now these earthwork sets save in the drawing, so if I close this down and someone else opens the drawing and they open up Earthwork Processor, this information will be there. So that's the gist of what I wanted to show you guys. Kind of a little recap. I wanted to underscore what is happening with those surface calculations behind the scene. Okay, we started with closed polylines for each depth region or each hold down region. We set the polyline elevations to be the depth or the hold down value for each of those regions. Earthwork Processor then created a depth surface from those regions, just polylines as break lines in the surface. Then here's where kind of the magic behind the scenes happens. We create a subgrade volume surface by comparing depth to FG. And remember, What is a volume surface? It's the delta between the two surfaces at a given point. If FG is at 800 and depth surface is at 1 at a given point, my subgrade volume surface elevation is going to be 799. And because we can't work with volume surfaces, we then paste subgrade volume surface into a subgrade tin surface. And then we have our actual subgrade surface. We can then use that to compare it to existing ground, or if we specify stripping depths, it'll compare to our stripping surface. So if you're wondering how you get Sim Project Suite, if you're on an old version of Sim Project Suite right now, just go to the About menu in your any one of your applications and download the latest version. The latest one is 22.0.0. If I go back to Civil 3D, here's what I'm referring to. Inside any of the apps, you can click About. It'll tell you what version you're on. This is .2. The latest, in fact, is .3. You can click Download Latest Installer. It'll bring you directly to a direct download page. Okay, that's for existing users and customers. If you do not have it yet and you're in the US, contact ATG USA. Canada, contact SolidCAD. Outside of that, you want to talk directly with CTC Software. And of course, there's free trials that you can download at ctcsoftware.com. So any other questions? I'm going to hang out. We'll address those questions now. We'll jump back into Civil 3D if we need. But that's what I want to show you guys today. Again, lots of other videos on YouTube for Earthwork Processor on how it works. It's a big time saver in terms of all that surface work that it does for you. And of course, all the annotation and reporting options it has are really helpful as well. So with that, I don't see any other questions coming in. So I thank everyone for their time. Wish you guys a wonderful day, and we'll see you next time.